Right, next step in your investigation, you want to start collecting your data. So there's a table here. Here's the way you're going to want to set it up. So this column here is going to be your number of bulbs. So let's call it number of bulbs. And you see here is voltage V volts. It's good to have a letter to represent every variable. So number of bulbs, we could also give it the symbol B, and it doesn't have units because it's just 1, 2, 3, or 4, or 5. And then we're going to put the numbers in. Could do up to 6 if you wanted to. And then you measure your voltages. And this is your first trial. So we're going to call it trial 1. Then you measure for 2, you measure for 3, measure for 4, measure for 5, and then start the whole process again, right? Take your circuit apart, put it back together, and then measure the voltage for 1, 2, 3, 4, 5 bulbs again. Right, once you've got all of your measurements, by the way, for achieved, you can actually get away with just doing one set of results, but for merit and excellence, you need to do multiple trials and taking the average. So when you've taken measured the voltage of one bulb 4 times and got 4 slightly different results, what we want to do now is find that average voltage. So let's call it voltage average. And again, the symbol for voltage is V, and the units, V for volts. And actually, the units there shouldn't be the word volts, it should actually be the symbol V, is correct, not the word. Now, how do you find the average of these 4 numbers? Well, the average is the in-between number. So if I look here, I see the highest number here is 11.11, and the lowest is 11.05. So the average is going to be somewhere in between the highest and the lowest. The way we calculate that is you take to find the average of 4 numbers, you add those 4 numbers together and you divide by 4. So I'm going to go 11.07 plus 11.05 plus 11.11 plus 11.10. Add them together, divided by 4. Right, so I get 11.08. I'm going to round it to the same number of decimal places as the rest of my values. 11.08, and check. This number here should be something very similar to these numbers here. If your average that you calculated is way different, then you've made some sort of mistake. So continue take the averages of your own values. Don't just copy my data. You've got to make your own measurements, calculate your own averages. You can also calculate all of these averages in Excel, and I'll show you how to do that in the next video. However, you can choose. You can do it with a calculator, or you can do it on Excel. Right. Going on to the next part. Right, so this is a write-up for the investigation. You've got to explain what your variables are. So first you've got to explain what is your independent variable. Remember, the independent variable is the thing that you are changing each time, right? So in our circuit, we changed the number of bulbs. So the watt is the number of bulbs, and you can give that, if we give it the symbol P, you can write that in as well. How? So how, just a brief explanation of what you're doing to change the number of bulbs. By adding in more bulbs in series. We're not adding them in parallel, we're adding them in series. And then the range is the number, like is the range of different values you can have. So the smallest number of bulbs that we had in our circuit was 1, and the largest number of bulbs that we had in our circuit was 5. So for range, I'm just going to write 1, 2, 5. The dependent variable is the thing that we measure. So we change the number of bulbs and then we measure the voltage. The voltage of a single bulb, it's the symbol V. And how do we measure it? Well, we use the multimeter. Using the multimeter or voltmeter. Control variables. So the control variables are all of the things that you need to keep the same. Each time you need certain things in your experiment to stay the same to make sure it's a fair test. And for merit, you need to mention at least 2 good control variables. I suggest trying to write 3 or 4. In case I disagree with some of them. So let's think about the things in our circuit that would have to stay the same. Well, we've got to keep the power supply on the same voltage the whole time. So voltage of the power supply. And if you know what the voltage was, then write it down. 12 volts. How it will be controlled? Just keep the power pack on the same setting. Simple. What else needs to be the same? Well, think about even if you did this on FET, you've got to actually be thinking about how you do the experiment if you're using actual equipment. So using the same pieces of equipment, like particularly the same wires and the same bulbs, is going to be important. So same, we could write those as 2 separate things. Same bulbs. And in this experiment, it's important, if you look at the bulbs, there are like different brands of bulbs and different sizes of bulbs. So we'd want to make sure that we were using bulbs that were all the same as each other. So choose bulbs that are all the same. Same wires. Keep the wires. Keep the same wires for the whole experiment. Other control variables, the temperature of the circuits can have an effect as well. So if the circuit's getting hotter and colder all the time, then that's going to have an effect on your results. one way around that is if you keep the circuit on the whole time and don't let it cool down, then it's going to stay at a pretty much a constant temperature. So circuit at a constant temperature, keep the circuit on the whole time. I suppose the other way that you could do that is actually only turning the circuit on for very brief amounts of time, so it doesn't get too, so it doesn't have a chance to heat up. Could be a way of getting around that as well. Any other sensible control variables that you can think of? Same multimeter settings. Accuracy improving techniques. Here's a section in the electricity booklet on accuracy improving techniques. Right, this is page 24 of the electricity booklet. Right, so under writing a method, accuracy improving techniques are all the little tricks that you have to make sure that your measurements are as accurate as possible. So repeating measurements and averaging them. Remember, so we measured the voltage of one bulb and we repeated that 4 times and found the average. That is an accuracy improving technique. Why it improves accuracy? Well, that's something that you can discuss that would go towards an excellence. So you've got to just use the technique for merit, but explain the technique, explain why it improves accuracy is just one thing you could do for excellence. Using the most accurate measuring devices available, or the smallest measurement scale. So on the multimeter, you can set multimeter to like a 2000 volt setting or a 200 volt setting or a 20 volt setting. By using the smallest possible scale, it gives you the most accurate number. So that's another accuracy improving technique. Waiting for fluctuations to settle. So on the multimeters, when you plug the multimeter in, you'll see the numbers, they go up and down a little bit for a while, and then after a while they tend to settle on a final number. So waiting for those fluctuations to settle is another good accuracy improving technique. Those would be the main ones that you would talk about for this particular experiment, but there's some more here as well that might apply to other experiments. So writing down those accuracy improving techniques there. Unless you're going for excellence, you can leave those boxes blank. And then method. So the first method that we had up here, this is like the draft method. If you are happy with the draft method and you did that well, then you don't have to write out the method again. Sometimes you end up doing something different to what you originally planned. So maybe this was the method that you thought you were going to do, but then you ended up doing something different. So that's why these 2 chances here to write the method. You do not need to write it out twice. Right, and last part, processing and graphing. I'll go into this in the next video. Briefly, you need to present a graph, and that graph can be drawn by hand or it can be done on Excel. And I highly recommend doing it on Excel because Excel will also give you the formula. So the mathematical formula from the graph is required for merit.